Hey, sixth graders, and in this video today, we're going to go through the next section of class notes in our Earth's Changing Surface unit. So let's start by making sure we have the document open. You might need to go search in your drive for the doc or scroll down to the last homework assignment for class notes. Document is called Class Notes, Earth's Changing Surface, 6H. Search that in your drive, you should find it. This point, if you need to pause it to do so, go ahead and do that and then come back to the video. We are through all of this stuff already, and we are going to examples of erosion and deposition. And today we're going to talk and focus first on large scale erosion, and then that's number one here, and then we're going to move to number two, running water river systems. And that's what's the main focus is going to be in terms of the information, as we're going to go through 2A, 2B, 2C. Okay, those three under two. So we're going to get through all that today. So let's go ahead and get started. Move myself here over to the Grand Canyon. All right. Mass movement. Mass movement. So mass movement is large scale movement, and there are two factors that affect it: rainfall and gravity. I think for some types of mass movement, you probably have heard of them. You might have even seen some in the news, because when they happen in areas that are populated with people, it can be pretty devastating when you have some of these. But there's also other types of mass movement that you're probably less familiar with, because they don't have dramatic effects, or maybe that's not the right way to say it. Not dramatic effects, but they aren't causing harm to people, and so they're not as noticeable even. And that's because some of them are fast and some of them are slow. I think the ones that are fast are the ones that are really dangerous and can cause lots of damage if they happen in areas that are populated. The slow ones maybe not necessarily as dangerous, because they're not like instant, but they still can be dangerous in the long run. So some examples of mass movement: landslides, mud flows, slump, and creep. So you might have heard of landslides, is my guess, and probably maybe even mudslides or mud flows. Slump and creep are the ones that are slower and are less familiar. Okay, but all of them are taking a big amount of land and sediment and moving it at the same time. So let me just throw in a couple examples here of, get myself out of the way over here. Here's some landslides. It looks like it's the same, but it's not. Two different locations here. These are in China. A mud flow. Here along a cliff, you can see an example of slump. Slump is like this whole section used to be up here, and over time it is slowly kind of sliding down the cliffside there. It's another example of it. Not quite as steep of a cliff, right? Or as high as a cliff. But all of this used to be up there, and it is slowly sliding down. But all of this is moving at the same time, so that's why it's classified as mass movement. And then creep. I mean, just think about something that is creeping along, right? It's going to be really kind of slow as it's moving along, and that's what's happening here. It almost looks like on this hillside here, the land is slowly eroding, and you can tell by the shape here of where this tree trunk used to be, and it's slowly happening over time, right? It's probably not as obvious to see as here. So you'd have to look for clues like this tree here is a really good one. All right, so those are mass movements, and we're not going to spend a lot of time on those. You just need to understand that mass movement is large scale movement, and it's a combination of rainfall and gravity that causes these events to take place. And they're either big dramatic events that are fast or could be slow over time. All right, so let's get to kind of the main part of what this video is going to be about, and that's water. Okay, and so we're going to focus on the erosion part of water as well as the deposition part of water, and then look at rivers and see where there's actually a combination of erosion and deposition happening in the same location at the same time. Okay, so you're on number 2 on your document here. Okay, so we talked about in the very first video and one of the very first slides how the water cycle is driving lots of erosion on Earth, right? And moving water is going to be the major agent of erosion. It just is. It causes the weathering to happen, but then it's the moving water, so it's able to pick up that sediment and actually carry it along. And so it's a major agent of erosion. And so it's really important to know what's going on here with water. So one of the things that happens is surface runoff, right? So water can be absorbed into the ground when it rains. You get this soggy ground and stuff like that. But the ground can only hold so much, right? And so the water that stays up on the surface, then we classify that as surface runoff, and that can really cause a lot of this erosion. It's a major factor in cities and areas because every time you build and you add roads or parking lots or buildings, you're taking away soil that can absorb the water and you're creating more surface runoff. So one of the ways that architects and engineers deal with this, and maybe you've noticed this, is that when they build new buildings and shopping centers and things like that, they usually have this area where lots of water kind of collects and it almost makes like a lake. We even have one here right outside the Beechwood Middle School parking lot, and it's kind of like in the corner by the parking lot and where the football field is. And it's this kind of like holding place where water drains from our parking lot and from the football field and all this stuff, and it goes there, and it's a big area and it almost turns into like a pond or a lake when it rains really heavy, because then that slows the surface runoff down and then just slowly releases the water then into creeks and rivers and streams, whatever the watershed might be. And so you see that too. If you've ever been to Pinecrest to go shopping, if you go in through the front entrance, they have a huge, it looks like a lake or a pond, and it's got a really tall fountain that shoots off, right? Well, that water is there because of the runoff from that development. So all of the little sewers that are there along the streets and sidewalks and things all go to that lake, and the water is held there, so then it is then slowly released into the watershed. Otherwise, when you have lots of surface runoff, you get lots of erosion because that means there's lots of water running. And so that's a big issue when new buildings or shopping centers or whatever is being built and you're taking away some of the soil that can absorb it and reduce the runoff. You have more runoff. And so you have to figure out, well, how are we going to deal with this so that we don't have a ton of erosion? And so one of the solutions are building these big retaining lakes or ponds to hold the water. When we have this moving water, right, we can get all kinds of effects. So one of it is that over time you get small little streams. Then you can get rivers, and the rivers create river valleys. Like we have the Cuyahoga Valley with the Cuyahoga River. Go a little bit east, and you have the Chagrin Valley caused by the Chagrin River. And then over time, and depending on how much water, you can even build things like canyons, right? Can happen because there's so much erosion that has taken place over a long period of time. Okay. Oops. Some pictures. Notice in that picture, some of the white part here, meaning that the water's moving pretty fast. We're going to talk about that here in a moment too. And here's one that's slow. So remember in class, we talked about how the speed of the water indicates how much force the water has. So the more force it has, the more erosion it's able to do because it's able to pick up and carry more sediment because it's stronger, right? Think about it. If you give more force, it's more strength. And so those river systems or water systems that are moving fast are going to be able to not only weather more, but also erode more and take that sediment with them, and can cause greater effects. Well, just like we talked about before, eventually, though, water slows down. And when water slows down, it has less force. And when it has less force, that means it's not able to carry as much sediment anymore. It's not as strong. So when does water slow down? Well, it usually slows down when it empties into or enters into a larger body. So if a stream enters into and feeds into a larger river, when it reaches that river, the water slows down. The best examples to probably just think of, though, off of the top of your head would be like a river emptying into a big lake or into an ocean. When it slows down, there's less force, and so the sediment that it's carrying now gets deposited. And a big effect of this that you can see are river deltas. Look at all of this brown. This is from sediment. Now, it doesn't mean that it's polluted. This means that there probably was heavy rain, and so there was lots of sediment that was kind of brought into that river, and it's carrying it through this river here, and then it empties into this big lake, and it just starts to deposit all of this sediment. And over time, it fills up, and you actually can get the sediment above the water, and you have little pockets of land and things too. So there's another one there. And there you can see, this is actually above the surface of the water now. And you even have some green on here, so some plants have grown over time because the sediment has been there for so long. So river deltas are a big effect of the deposition of sediment when water slows down for the running water. The running water slows down. All right, so that takes us then to when erosion and deposition are actually happening at the same time. And we see this in rivers that have lots of turns in them. So we call a turn a meander, okay? And that's like a bend or a turn in a river meander. And these bends, these meanders, are caused by both erosion and deposition happening at the same time. And it has to do with the same idea in terms of the force that the water has. And the reason it has different force is because it depends on the speed. All right, so this is a really important concept to understand. Water moves fastest on the outside of the curve. And because it's moving faster, it has more force, so it causes erosion. Water then moves slower on the inside of the turn, causing deposition. That happens again because it's not moving as fast, so it doesn't have as much force to carry the sediment, so the sediment falls out, it drops. So let's talk about why that happens, okay? I know that many of you probably know that if you go out onto the track for PE class or to run a race for track or something like that, that you like to be on the inside of the track. And why is that? Well, you know that if you're on the outside of the track compared to the inside of the outside of the track, you would actually have to travel a greater distance. There's more distance to run on the outside than on the inside. So you think that, that makes you faster. Well, technically, that doesn't make you faster, right? That just makes you having less ground to travel. So think of this. Take the same situation, being out on a track, you and your friend. You are on the inside, they are on the outside. And if the goal is for you guys to stay side by side the entire time, when you guys get to a turn, who has to run a little bit faster to keep up? The person on the outside has to run a little bit faster to keep up so that you guys are right next to each other the entire time during the turn. The person on the outside has to go a little bit faster than the person on the inside. Why? Because they have more distance to cover. So they have to have more speed to cover it in the same amount of time that you would have on the inside. And so that's what's happening here on the river turn. On this river turn here, along the inside, the water slows down. And so you start to get deposits. And then you start to see it actually on the inside of the turns. On the outside, for the water to stay right next to it as it's coming through the turn, as it's coming through the turn, it's covering more distance. So it's going to have actually have a little bit more speed. And so because it has a little bit more speed, there's a little bit more force. Now, over time, this continues and continues, and you get greater and greater bends. Eventually, you get to a point where the water actually can't make the turn anymore because it's almost like greater than a 90-degree turn. It's almost like it has to turn and turn around, almost like a U-turn or something. And water's not going to do that, right? And so what happens is that it actually cuts a new path of the river. And then it leaves this U-shaped lake, as you see here, and that's called an oxbow lake. That used to be part of the river, but it's no longer connected to it. Okay, so this is a really important concept for this unit to understand, is where erosion and deposition happens when we have a river meander. So water moves fastest on the outside, so that's where there's erosion. Slowest on the inside, that's where there's deposition. Guarantee there's going to be questions about that on a homework or a test. Here's some pretty dramatic examples of what we're just talking about, right? And so take a look, focus at, to start here, focus at the inside turns for all of these. And you can see that there's almost like beaches or sand. That's because there's deposition happening there because the water is going slower on the inside. So you can see it here. You can see it on the inside turn here. And then when it turns this way, look at this here. All of this here. And this is a great one because look at on the other side. You can see this little cliff, right? It's super steep over here. Why is that? Because it's been eroding on the outside, but depositing on the inside. Now, I'm not going to do it here in this video, but on Google Earth, if you go through satellite images of the Mississippi River and you start traveling along it with satellite images, you see all of these meanders and you see all kinds of oxbow lakes. This one's getting really close to becoming an oxbow lake. Eventually, this water isn't going to be able to turn all of the way, and it's probably going to cut off up here at the top and just go straight across, and then this will just become a lake because the water isn't going to be part of the river system anymore. Okay. That covers the video for today in the section that we wanted to get through. Water, erosion, deposition was the focus today. Make sure that you have the notes copied down. If you need to go back because you were typing and not listening as well, go back and maybe listen to help you. But then I will see you next time in class. Have a good day.